first example, we have 2 times 2x squared plus y squared dx minus xy dy. This is our m, and this is our n. M is the coefficient of dx, and n is the coefficient of dy. Since n is simpler, as you can see, which is very obvious, we use the substitution y equals vx. And if y equals vx, that means dy, which is the derivative of y, is equal to v dx plus x dv. We simply use the product rule for integration. And then we need to substitute these to both our y and our dy. So we have 2 times 2x squared plus y. Instead of writing y, we write v squared y squared. I mean v squared x squared, because y is equal to vx, v squared x squared dx minus x times again our y is equal to vx, and dy is equal to v dx plus x dv, and then this is equal to 0. Now the next step is to simplify. As you can see in our equation, we can factor out x squared. So we have 2x squared times 2 plus v squared dx minus x squared v times v dx plus x dv equals 0. And we divide everything by x squared. So divide everything by x squared. This cancels out, this cancels out. 0 divided by x squared is still 0. So what we have left is 2 times 2 plus v squared dx minus v times v dx plus x dv equals 0. Or to simplify it further, we distribute already our v here. So we have v squared dx, and since this is negative, so this becomes minus vx dv equals 0. And as we can see, we have dx here and dx, another dx, two terms with dx, derivative of x. So we can combine these. Okay, we can factor out dx as a common monomial factor, which would result to, when we distribute this, so we have 4 plus 2v squared, and we factor out dx. So what is left is minus v squared, and this is dx minus vx dv equals 0. Now the next step in the solution is to simplify this. So 4 plus 2v squared minus v squared is v squared dx minus vx dv equals 0. The next step now is to separate the variables. We have learned last time, our topic is separation of variables. So here we separate the variables. As we can see, we have here in this term v and then dx, and here vx dv. So we separate the variables such that all the dx are here, all the variables, this function is a function of x, and this function becomes a function of v. So as we have learned separation of variables last time, this becomes 4 dx over x minus, so x transfers here, we have v dv over 4 plus v squared. This can be easily integrated because here this is simply ln of x, and this one, if this is our u, if our u is equal to 4 plus v squared, then our du is equal to 0 plus 2v. So since we have already v here, we simply need to put 2 here and then 1/2 before the integral sign, so that we can easily integrate. We simply adjust the integrand. Alright, so that is, since we have we need 2v, and since we only have v, we write 2 here, and then when we integrate, since we place 2 here, we place 1/2 here, adjusting the integrand. Alright, so this becomes ln of x minus, we have 1/2 ln of 4 plus v squared equals, so it's better to place here ln of c. And in order to eliminate the denominator of 2 here in the second term, we multiply everything by 2. So we have 2 ln of x minus, this cancels, ln of 4 plus v squared equals ln of c. 2 ln of c. And let me erase everything first. So we have now 2 ln of x minus ln of 4 plus v squared equals ln of c. 2 ln of c. Now by the principle of logarithms, we have ln of x squared minus ln of 4 plus v squared equals ln of c squared. And then take note that we use the substitution y equals vx. So therefore, we now substitute back our original equation. That means v is equal to y over x. So substitute this to the v found in the equation. We have ln of x squared minus ln of 4 plus y over x squared equals ln of c squared. And then we simplify this. We have x squared. This becomes 4x squared plus x squared divided by x squared. 1 times y squared is y squared. So this becomes minus ln of this, ln of c squared, ln of x squared. And what we do is we can apply the principle of logarithm, which states that ln of x over y is equal to ln of x minus ln of y. So this becomes ln of x squared minus ln of 4x squared plus y squared. And since this is negative, this becomes positive. Ln of x squared equals ln of c squared. And the next step is to transpose um, this to the other side, and ln of x squared plus ln of x squared is equal to 2 ln of x squared equals ln of 4x squared plus y squared plus ln of c squared is now equal to ln of c squared times 4x squared plus y squared. This is 2 ln of x squared, or simply equal to ln of x squared or ln of x to the power of 4 by the principle of logarithm once again. And the last step is to raise everything to e. Raise everything to e so that we can cancel out ln. So the final answer would be equal to x to the power of 4 equals c squared times 4x squared plus y squared. This is now our final answer. Another example is xy dx minus x squared plus 3y squared dy equals 0. So this is our m and this is our n. Again, but just by inspection, we know that m and n are homogeneous to the second degree. We can, if we insert here lambda to both functions, we can easily factor out lambda and it will result to a lambda in the second degree. So both functions m and n are homogeneous to the second degree. And since m is simpler, it is only composed of xy, then we use the substitution. Okay, since m is simpler, we use the substitution. We let x equals vy. And if x is equal to vy, dx is equal to v dy plus y dv. That is by product rule in differential equations. So we substitute to the original functions. We have, instead of writing x, we write vy times y. Instead of writing dx, we write v dy plus y dv. Minus, instead of writing x squared, we write v squared y squared plus 3y squared dy equals 0. Now, just by inspection, we know that we have y squared as a common monomial factor. That is v y squared, or I'll just we distribute v here, so we have y squared times v squared dy plus vy dv minus, I can factor out y squared. We have y squared v squared plus 3 dy equals 0. And then dividing everything by y squared, we have v squared dy plus vy dv minus v squared plus 3 dy equals 0 divided by y squared is still 0. Now, we can see that the next step would be to multiply, to separate the terms. So this would be equal to, and then we group the variables depending on their derivatives, the terms depending on their derivatives. So we have v squared dy plus vy dv minus we have v squared dy plus 3 dy equals 0. Since this is, by the way, negative, so this becomes negative. So we can see that we can cancel out v squared dy immediately. And what is left is vy dv minus 3 dy equals 0. So again, we use separation of variables. We have v dv minus 3 dy over y equals 0. 3 dy over y equals 0. And then the next step is to integrate. So we integrate. V dv is, integral of v dv is v squared over 2 minus 3 ln of y equals, we can write instead of just writing ln of c, we can write 3 ln of c. Why is that? So that we can easily group these two together. So we have now v squared over 2 equals 3 ln of y plus 3 ln of c. And we multiply 2 to both sides. We multiply both sides by 2. So this results in v squared times equals 2 times 3 ln y plus 3 ln c. So distributing 2, we have v squared equals 6 ln y plus 6 ln of c. And then we can factor out. We can then factor out 6. So this results to v squared equals 6 times ln y plus ln of c. And then this becomes, by law of logarithms, this is ln of cy. So then take note that, recall that we use the substitution x equals vy. So we can use that to substitute for our v again. So that means v is equal to x over y, right? So this becomes x over y squared equals 6 ln of cy, which means this is x squared equals y squared. 6y squared ln of cy is equal to x squared. So x squared is equal to 6y squared ln of cy. This is the solution to the differential equation xy dx minus x squared plus 3y squared dy equals 0. Our third example is one which is a little bit complicated, but applying the rules for solving homogeneous functions, it is still solvable. So we have xy prime equals 4x squared plus 7xy plus 2y squared. So this becomes x squared. This is dy over dx equals 4x squared plus 7xy plus 2y squared. Transposing the x to the other side, we have x squared dy equals 4x squared plus 7xy plus 2y squared. This is dx. This is equal to, so this is equal to dx. And if we transpose this to the other side, we have x squared dy minus 4x squared plus 7xy plus 2y squared dx equal to 0. Now, this is m, right? Because m dx plus n dy. As you can see, m has 3 terms while n has 1 term. So it is very obvious that n is simpler. And since n is simpler, we use the substitution y equals vx. Or that is dy is equal to v dx plus x dv. So we use these substitutions. So x squared is equal x squared dy is now v dx plus x dv minus 4x squared plus 7x. Instead of writing y, we write vx plus 2. Instead of writing y squared, we write v squared x squared dx equals 0. Then it is obvious to see that x squared can be cancelled out, right? So x squared, x squared, x squared. So we factor this out, and then we have x squared here. We divide everything by x squared, so x squared cancels because 0 over x squared is still x squared. So the whole equation is still equal to 0, but x squared cancels. So v dx plus x dv minus 4 plus 7v plus 2v squared dx equals 0. And then what we have now are two terms with each containing the variables x and v. So what we need to do is to group the variables having the same differentials. So this means that we can distribute the this dx, and so we have v dx plus x dv minus 4 dx minus 7v dx plus minus 2v squared dx equals 0. And then we group the variables containing dx. So we have x dv, then x dv plus v dx minus 4 dx, 4 dx minus 7v dx minus 2v squared dx equals 0. Okay, so we combine the terms that can be combined. So here we have v dx minus 7v dx. So this becomes negative 6v, right? So x dv plus, so v dx minus 7v dx is negative 6v dx minus 4 dx minus 2v squared dx equals 0. Okay, so let's continue. we have now x dv minus, we factor out dx once again, so we have negative xv plus 4 plus 2v squared dx equals 0. So we can now separate the variables because we have only v's here and we have only x here. So by separation of variables, we have dv over 6v plus 6v plus 2v squared. We'll just arrange them according to their exponents. So 2v squared plus 6v plus 4 minus dx over x equals 0. And then we integrate. Now, as you can see, this is very easy to integrate because this results to ln of x. But how about this one? This is where we need to go further. This is where it becomes a little bit complicated, but it is still doable. So we separate this into partial fractions, but before we can do that, we need to first factor 2v squared plus 6v plus 4. Okay. Okay, so this whole expression, this expression is now equivalent to this expression, and this expression is very much already integrable. We can already integrate this expression. So we substitute this expression with this expression. So that is integral of, instead of writing 1/2 dv, instead of writing 1/2 dv over v plus 1 times v plus 2, we write instead 1/2 over v plus 1 minus 1/2 over v plus 2 dv. Okay. So this is now very much integrable. That is, we distribute the integral, so we have 1/2 ln of v plus 1 minus 1 half of ln of v plus 2. So the next step is now to combine everything. We combine everything. Let me erase everything first so that we will have some space. So we have resolved this already to partial fraction, and we know that this integral is equal to 1 half of ln of b plus 1, this is our a, minus 1 half of ln of v plus 2 minus ln of x equals, we write ln of c instead of just writing c. And then the next step is to multiply everything by 2. So we have ln of v plus 1 minus ln of v plus 2, then minus 2 ln of x equals 2 ln of c. Okay? Then we transpose this to the other side. We have now equal to 2 ln of x plus 2 ln of c, or that is ln of x squared plus ln of c squared, which we know is equal to ln of c squared x squared. By the principle of logarithm, this is equal to ln of v plus 1 over v plus 2, right? So what we have is ln of v plus 1 over v plus 2 equals ln of c squared x squared, or that is ln of v plus 1 over v plus 2 equals ln of c. So we have ln of v plus 1 over v plus 2 equals ln of cx squared, because c squared x squared can be rewritten as cx squared. We raise everything to e. We have v plus 1 over v plus 2 equals cx squared. And then we substitute back the y to v. Remember that we use y is equal to vx, so therefore v is equal to y over x. So we substitute here. We have y over x plus 1 over y over x plus 2 equals cx squared. And so the task remaining is to simplify y over x plus 1 and y over x plus 2. Okay, so that is y over x plus 1 is equal to x as the LCD, x divided by x, 1 times y is y plus, so this is x. And on the other hand, y over x plus 2 is equal to x as the LCD, x divided by x, 1 times y is y plus x divided by 1, x times 2 is equal to 2x. So this becomes y plus x over y plus 2x over x. Okay. This one becomes y plus x over x times multiplied by the reciprocal x over y plus 2x. X cancels, and what we have left is y plus x over y plus 2x. And so we can substitute this here, and we have y plus x over y plus 2x equals, so we have y plus x over y plus 2x equals cx squared. Or we can say that our final answer is y plus x equals cx squared times y plus 2x. Okay, so this is now the solution to our differential equation using homogeneous, the process for solving homogeneous differential equation. Okay, you can practice solving the other problems in your module or in the book I have sent in your Schoology. So thank you everyone, and see you next time.